Okay, so in this correct video, we'll be looking at metric and American conversions, as well as temperature and currency conversions. Just like I do with the notes in the normal class with the correct class, I won't do every single problem here in these correct videos, but you know that you have a solution key to go by. It's just, like I said, designed to give you more practice to reinforce the material taught in the class. All right, so we'll start here with metric measurements. The metric system is measured in length, weight, and capacity. Length is the meter, weight is the gram, and capacity is the liter. And so you have here in the center the base unit of the meter, gram, and liter. And then moving to the right are your smaller measurements, deci, centi, milli. Moving to the left are your larger units, deca, hecto, and kilo. But essentially, the nice thing about doing metric conversions when you're within the metric system, so for example, if I wanted to convert a meter to a decimeter, I only have to move my decimal one place to the right. If I were going from a decameter to a centimeter, I start here at this decameter and I would go 1, 2, 3 places to the right. Let's say you're sitting here at a milligram and you want to go to a gram, milligram, 1, 2, 3 places to the left. So, what will happen is that you will pick wherever you're starting from, that base unit, and move your decimal how many places it takes to go to that intended unit. The only thing you have to pay attention to down here below on the number line, you'll see here that I have your base unit of liter, gram, and meter here in the center. And you'll notice that whenever you move to the right to deci, you'll notice that exponent up there is just one place. Move again centi, and so you've just another one place. Move to milli, another one place. But when you go from milli to micro, notice how that exponent went from a -3 to a -6. That means there you would be moving your decimal 3 places to go from a milli to a micro, so like a milligram to a microgram, for example. Again, if you were going from micro to nano, look at that exponent, those exponents there, that would be another 3 places. Even though it's physically only moving at 1, you would be moving your decimal 3 places. And then lastly, from nano to pico would be another 3-place decimal movement. The same thing happens when you move to the left. Deca is just a 1 decimal movement, to hecto 1 decimal movement, to kilo 1 decimal movement. You'll notice how it's just counting up by 1 each time. But when you go from kilo to mega, look at that exponent, it goes from 3 to 6, so you'd be moving it 3 places. From mega to giga, another 3 places. And then from giga to tera, notice these exponents, another 3 places. So just be mindful of that. But other than that, hopefully you'll see that moving within the metric system is perhaps a little simpler than the other conversions that we were doing, because you are just doing just that. You're moving your decimal. So looking at here, example 1, it says you have 4.10 centimeters, and I want to convert that to meters. So if I'm sitting here at a centimeter and I want to convert it to a meter, centimeters, this is where I'm at, and so I'm going to get to that base unit there of a meter. I'm going to have to move it 1, 2 places to the left. So I'll be moving my decimal 2 places to the left. So I'm going to write this out here for you, 4.10. Take that existing decimal and go 1, 2 places, and insert it there, and you'll insert a 0 for a final answer of 0.041. That 0 on the end, you can technically drop it, but you can also keep it as well. Okay. I think what I'm going to do is I'm just going to go down here on the right-hand side. So number 3, 0.08 decameters to a centimeter. So if I'm at a decameter, and if you get lost in the terms of the conversions here, deca abbreviation is DA. So you're here at decameter, and we are trying to go to a centimeter. So decameter is here. I would move it 1, 2, 3 places to the right. So this time I'm going to be moving that decimal 3 places to the right. So take this existing 0.08 here, take that decimal point now, I'm going to go 1, 2, 3 places, insert a 0 there, and then that would give us a final answer of 80 centimeters. Well, you can drop that 0 in front there, in front of that 8, and that would give you your final answer there of 80 centimeters. And then let's look at number 5, 121 kilobytes to a gigabyte. So if I'm sitting here at a kilobyte and I want to go to a gigabyte, I'm moving it 1, 2 places physically, but notice these exponents, I'm really moving it 6 places. So I'm going to be moving that 6 places to the left. So I start here with my 121. And remember, if you don't have a decimal in your number, it's assumed to be sitting at the end, and I go 1, 2, 3, 4, 5, 6, and put that decimal point there, and then insert zeros, and then that gives me a final answer of 0.000121 gigabytes. Just like I tell you in the Math 143 class, this is a good spot now to just to make sure that you're tracking is just pause the video, you try 2, 4, and 6, check yourself with the solution key and make sure that you're good. I'm going to go on down and do number 7. Here we say that a medicine bottle has 65 pills in it. Each pill has 120 milligrams of an active ingredient. They want us then to figure out how many grams of that active ingredient are in the entire bottle. So I'm actually going to work this problem 2 ways, just to give you a feel for that. You know, if I work it one way and then you say, well, I would have done that entirely different, you know that you can do it entirely different. So here's 2 viable ways to do this problem. You could start out with your 65 pills and say, well, I know that there's 120 milligrams of medicine in each of those pills, and just go ahead and multiply it times 120. So 65 times 120 will give you 7,800 total milligrams in the bottle of the active ingredient. Now convert those milligrams to grams. And to go from a milligram to a gram, you're going to start, milligram's going to be over on the far right. If you're up here in the table, milligram would be over here on the far right. And to get to a gram, you'd go 1, 2, 3 places to the left. So I take this existing decimal, so since I don't have one, it's here at the end, then go 1, 2, 3 places to the left. So it would be 7.8 grams in the bottle. Maybe you were thinking, well, I would have done that differently. Here's another way. You could start out with the 120 milligrams right from the start and convert it to grams. And so to convert the milligrams to grams, you're still going to have to move that decimal 3 places. So start back here at the end and go 1, 2, 3 places. So you have 0.12, fix that there, 0.12 grams. Now multiply that times the 65 pills in the bottle, and then that should land you also at 7.8 total grams. Okay, so either way is perfectly acceptable. Okay, I think at number 8 and 9 you should be good to go with both of those. I'm going to flip it on over. In number 10, this one now is looking at, you're in the metric system, but they're asking us to go from a metric unit to an American unit. So let's look to see how that plays out. The only time we can do our decimal movement is if we're going from metric to metric. So once you go from metric outside of the metric system, you've got to go back to our typical conversions like we were doing before with the chains. Okay. So here they're telling us that the length of the sleeve of a dress shirt made in Italy is 92 centimeters. They want us to express that length into the nearest inch. So essentially they want us to convert these 92 centimeters to inches. If we were going from centimeters to meters, or another unit within the metric system, then we could have, like I said, like we were doing just before, moved our decimal. But here we're going to go from centimeters to inches. So we'll look on our formula sheet and ask ourselves, is there a conversion that will take you directly from centimeters to inches? And down towards the bottom, you should find that there are 2.54 centimeters in 1 inch. So in order to get rid of those centimeters, we put centimeters on the bottom, inches up top. There are 2.54 centimeters. That's since the 2.54 is associated with the centimeters, then the 2.54 is on the bottom in 1 inch. Then the centimeters cancel out. We multiply straight across, 92 times 1. On the bottom, 1 times 2.54. Then do our division here, and that would give us 36.22. They want it to the nearest inch, so we're trying to figure out what to do with this 6 here. That 2 behind it tells me to keep it. So I'm looking at 36 total inches. Okay. All right, let's move on down then to number 11. In number 11, they tell us that the elevation of the Lassen Peak volcano is over 10,000 feet. The elevation of the Fuego volcano is over 3,000 meters, and they want us to know which volcano is higher. So when you see a problem like this, you don't have to convert both of these. What needs to happen, in order for us to be able to answer this question, we need them both to be in the same units, meaning we need both of them in feet or both of them in meters. So the only way that that's going to be able to happen is that if we convert one or the other. I believe on the solution key I converted the feet to meters. So I think I'll just do it the opposite way here, okay? I'm going to take the Fuego volcano, which is 3,763 meters, and I will convert from meters to feet. Once I get that into feet, then I'll know that Fuego is so many feet, and I already know that Lassen Peak is this many feet. To get rid of those meters, put meters on the bottom. You'll notice on your formula sheet that you can go directly from feet to meters. Don't get meters and miles mixed up. Meter is just M. Miles will always have an MI beside it. So there are 3.28 feet, and the 3.28 is associated with the feet. Feet are up top, so the 3.28 is up top with the feet in 1 meter. Meters cancel out. I can stop because I'm at my feet now. I multiply straight across, and you should get 12,342.64 feet. So this is Fuego here. And then we know that Lassen Peak is over 10,000 feet, but if Fuego's over 12,000 feet, then clearly Fuego is taller. So that would be final answer there, okay? But again, you only need to convert one of them. On the solution key, I converted the feet, the Lassen Peak, into meters, and he went that way for you so you could see it, okay? And that kind of got chopped off there. That's a 12,000, okay. All right, so let's move on down. Let's see. In number 12, I want to do that one because there's more than one way to do this problem, and I want to make sure that we're clear on that sometimes that depending on the way or the route that you choose to make your conversion, there might be a discrepancy in your answer. So looking at number 12, I want to convert 40 pounds to grams. So let's start with our 40 pounds over 1. And we look on our sheet, and can we go directly from pounds to grams? And unfortunately we can't, but you got a couple of options. You could take yourself from a pound to a kilogram. That's going to be the first way I tackle it. So to get rid of those pounds, the pounds on the bottom, and go to kilograms. And we know that there are 2.205 pounds in 1 kilogram. Now at that point, pounds cancel out, and I'm left with kilograms. I'm actually going to get out of my chain. I'm going to get my answer here because, and I know it's not the final unit, which is grams, but we know that to convert from a kilogram to a gram, I'm in my metric system, and I can just move my decimal. So what's going to happen at this point is I'm just going to multiply straight across, 40 times 1, and then on the bottom, 2.205 times 1. Then when I divide there, I get 18.1406. Remember, that's kilograms. I want to go from a kilogram to a gram. So now looking on our conversion to go from a kilogram to a gram, kilograms over on the left, gram is directly in the middle as a base unit. So that means I'm going to be moving 3 places to the right. 1, 2, 3. So that would give me then a final answer of 18,140.6 grams. So 18,140.6 grams. All right, like I said, let's look at this one a different way. Let's say you were thinking of it differently. You said, okay, well, there's 40 pounds. I can't go from pounds to grams directly, but I could take myself from a pound to an ounce. So if you did that, pounds to ounces, and there are 16 ounces in 1 pound. So at that point, pounds have canceled out. And then you notice on your sheet, well, I can go from an ounce to a gram. To get rid of those ounces, ounces on the bottom, grams up top. There are 28.35 grams in 1 ounce. Just pulling this from your formula sheet. Ounces cancel out. And at this point now, when I stop, I've got my final answer. All that I have to do is just multiply 40 times 16 times the 28.35. That should land you at 18,144 grams. And this is where it gets alarming to folks because they say, oh my gosh, well that's almost a 4 gram difference. Oh, I must have done something wrong. You didn't. It's just that you used a different conversion. 2.205 is an approximation. Likewise, 28.35 is an approximation. So neither one is wrong, and I guess it's up for speculation as far as which is a closer approximation. Okay, but either is a perfectly acceptable answer. Okay. All right, let's look at number 13 because something a little different happens in this one. In number 13, it says you've got a can contains 850 milliliters of motor oil. They want to know how many quarts of oil are in the one can. They want us to round to the nearest tenth. So 850 milliliters, and we're trying to get that to quarts. And if you'll notice on your sheet, you don't have any way to go from a milliliter to a quart. But if you notice, if you're also looking ahead too, if you think about, okay, well, a quart is associated with quart to a gallon and also quart to a liter. So we also can't take a milliliter to a gallon, but can you take a milliliter to a liter? And hopefully you agree, yeah, I can do that because that's in my metric to metric. I can just move my decimal place. So milliliter sitting over here on the right. To get to a liter, which is your base unit in the center, you're going to go 1, 2, 3 places to the left. So now you're starting with 0.850 liters. And now we can go from a liter to a quart. Get rid of those liters, put liters on the bottom. And on your sheet, it will tell you that there are 1.057 quarts in every 1 liter. Then at that point, liters cancel out. We know we can stop. My only unit I have left up there is quarts, which is what I want, and that gives me 0.898. And then it tells me to round to the nearest tenth. So this 8 here is in the tenth spot, and that 9 tells me to round that up, so to 0.9 quarts. Final answer. All right, move on down into number 14 and 15. This is looking at your temperature conversions. If you feel good with these two formulas, then you might want to pause the video and try the formula first for yourself. If not, here's another explanation with using these formulas. So they tell you number 14 that the recommended sage minimal internal temperature when cooking ground beef is 160 degrees Fahrenheit. They want us to convert that temperature to degrees Celsius and round to the nearest tenth. So the formula for converting to degrees Celsius, you use the C formula. C equals F minus 32 all over 1.8. F minus 32 would be up here in parentheses like so. So your Fahrenheit temperature, in place of F, you're going to put your Fahrenheit temperature, which is 160, minus 32 divided by 1.8. Me personally, I like to just take this in a couple of steps in my calculator, so I like to subtract and then divide. If you're going to do it all at one time, you have to use these parentheses. But I'm just going to go ahead and say, okay, well, when I do that subtraction up top, I get 128 divided by 1.8, which gives me 71.1 degrees Celsius. Final answer there. In number 15, they tell us that Old Faithful, whenever it erupts, the temperature, just before it erupts, the temperature of the water is 95.6 degrees Celsius. They want us to represent this in degrees Fahrenheit and round to the nearest degree. So the formula for Fahrenheit is equal to 1.8 C plus 32. So you have 1.8. In place of C, you're going to put the Celsius temperature, so that's 95.6. And then add 32 to that. And then from here, you're just going to do like a little bit of order of operations, or technically you can put all of that in your calculator at one time and you'd be good to go. I'll show a couple of steps here. Multiply, you get 172.08, add 32 to that. Then you get 204.08. Nearest degree, so I'm trying to figure out what to do with this 4. That 0 behind that tells me to keep it. So you're looking at 204 degrees Fahrenheit. Okay. And we'll flip it on over to the last page and look at some additional conversions. At the top several here, 16 through 19, are looking at conversions involving more than one unit. So I'm going to look at 16 and 19 with you. In number 16, it says that gas costs $3.27. All right. Oh, sorry. $3.27 for every 1 gallon. So I've got my money unit up top and my capacity unit on the bottom, so amount per gallon. And they want us to find this as a cost per liter. So the cost unit is up there and it's already correct, but they need us to get rid of these gallons. So in order to get rid of gallons, remember, in order for things to cancel out, they have to be diagonal from one another. So since gallons are already on the bottom, in order for it to cancel out, you've got to put gallons on top. And then you ask yourself, or look at your formula sheet, can you go directly from a gallon to a liter? And you can. There are 3.785 liters in every 1 gallon. Now look here, the gallons cancel out, and look at the units you have left. You have a cost per liter. So you have everything that you wanted. So now from here, we just multiply straight across. 3.27 times 1 up top, 1 times the 3.785, then divide, and you get 0.8639. Anytime you're talking about money, always do dollars and cents. So rounding to the nearest cent is the same as rounding to the hundredth spot. So here we're talking about 86 cents per liter. Okay. I definitely encourage you to stop the video now and try number 17. Okay. And maybe even try 18 as well. I'm going to do number 19 because 19 is a little bit more involved than 18, but 18 and 19 are similar to one another. In number 19, they want us to convert 10 miles per hour into feet per second. Okay, notice how here I put 1 unit up top and 1 unit on the bottom. It's always imperative that you do that. There's only one exception to that rule, and we'll talk about that when we get to conversions for drugs. So you have 10 miles for every 1 hour. Here, we want to convert our miles into feet and our hours into seconds. So we've got to convert both of these units. You can start with either one that you want. It doesn't matter. So to get rid of our miles, I would put I'll just start with the top first. To get rid of miles, I'd put miles on the bottom. And ask yourself, and looking at your formula sheet, can you go directly from miles to feet? And you can. There are 5,280 feet in 1 mile. So you have your 5,280 up here, 5,280 feet in 1 mile. Now at that point, the miles cancel out. You're not going to stop. You've got part of what you need. You've got your feet up top. You've got that, but you've got feet per hour. So I can't stop here. So I keep going. To get rid of my hours, since hours are on the bottom, I'm going to put hours up top. And we can't go directly from hours to seconds. We'd likely go from hours to minutes. And we know that there are 60 minutes in 1 hour. So now at that point, hours cancel out. So you're left with feet per minute. So we're almost there. One more step to get rid of those minutes, since minutes are on the bottom. Put minutes up top. And we can go from minutes to seconds. We know that there are 60 seconds in 1 minute. From here, those minutes cancel out, and I'm left with seconds. So I now have, you look at the only units you have left in this problem, feet up top, seconds on the bottom, exactly what you wanted. So you just multiply up top, and you get 52,800. And then on the bottom, you've got your 60 times 60. Just 3,600. I'm just ignoring, multiplying by 1, and so it's going to have me 3,600. Then after I divide here, I've got you rounded to the nearest hundredth, so 14.67 feet per second. Final answer. Okay. And then the last 2 questions deal with converting money. So you'll definitely want your formula sheet handy. I always ask that you use the formula sheet conversions as opposed to going online. Here you have 500 yen, and we want to convert those 500 yen into US dollars. So to get rid of the yen, we put yen on the bottom. And on your sheet, you can go directly from yen to US dollars. Everything on your sheet, all of the numbers associated, the actual monetary amounts are always going to go wherever you have US dollars. So if your US dollars are up top, then that number is going to go up top. If your US is on the bottom, then that number is going to go on the bottom. Another way to think about it is that your sheet tells you that 1 yen is equal to 0.008658 US dollars. At that point, then yen cancel out. 500 times that value there should put you at 4.329 which if we round that, we're talking about $4.33 in US dollars. Let's compare that down here in number 21. Say you start with 600 US dollars, and we would convert that to euros. So to get rid of your US dollars, you're going to put your US dollars down here on the bottom and go to euros. Remember what your conversion sheet is saying, that one of those alternative currencies, so 1 euro is equal to the US dollar 1.058 US dollars. Then at that point, the US dollars cancel out. I multiply straight across. I'm going to have 600 divided by the 1.058. And then I do that division. I'm looking at 567.11 euros. Okay. There. So my point again is that on your formula sheet, you're always going to have when you're doing currency conversions, the US is always going to be where the number is. So if the US is up top, then that monetary conversion factor is up top. If the US is on the bottom, then the monetary conversion factor is on the bottom, and then one goes with the other conversion. All right, let me know if you need anything. Thanks a lot.